For centuries, the fortunes of empires, cities, and entire economies have risen and fallen at the edge of the sea. Today, that edge is shifting again, quietly, massively, and at enormous cost. Just offshore from one of Europe's oldest port cities, Italy is redrawing its maritime boundary from the seabed upward, not out of ambition, but out of necessity. Global trade has outgrown the past. Ships are longer and heavier, storms are more violent, and the margin for error in modern logistics has nearly vanished. What is unfolding here is not a simple expansion, but a calculated intervention into geography itself. Thousands of tons of concrete are being positioned in deep water, while one of the Mediterranean's busiest ports continues operating just meters away. Every decision balances risk against reward, climate resilience against cost, speed against safety, global competitiveness against local impact. Most people will never see this structure. Yet its consequences will shape shipping routes, supply chains, and economic flows far beyond Italy's borders. So why would a nation invest billions in a structure the world may never notice? And how do you build a defensive wall in waters once considered too deep to conquer? To answer those questions, today we look beneath the surface of the Genoa breakwater megaproject. Don't forget to click on that subscribe button and like this video, as it's the best way to support this channel. On Italy's northwestern edge, along the Ligurian Sea, lies the port of Genoa, long protected by a breakwater largely completed in the early 20th century. For decades, that structure served as the port's first line of defense, enabling Genoa to grow into Italy's primary maritime gateway. Today, the port stands at the southern entrance to the Rhine-Alpine corridor, linking Mediterranean shipping lanes directly to Switzerland, southern Germany, and the industrial heartlands of northern Italy. But the breakwater that once made this growth possible was built for another era. It was never designed to accommodate today's ultra-large container vessels, nor the longer period swells and storm surges intensified by a changing climate. Its alignment constrains access channels, limits maneuvering space, and forces the largest ships to rely on increasingly narrow weather windows. What were once occasional disruptions have become systemic challenges, manifesting as delays, congestion, and shrinking safety margins. In a global logistics system now defined by reliability, scale, and precision, these limitations translate into a competitive disadvantage, especially when compared to Northern European ports that have already invested heavily in deep-water access, automation, and climate resilience. Modernizing the port of Genoa therefore becomes not an option, but a necessity, and it begins with a decisive intervention. A new breakwater pushed farther offshore to create a wider, deeper, and dramatically calmer access basin. By reducing dependence on favorable weather and enabling safer maneuvering for the world's largest vessels, the barrier removes long-standing bottlenecks and restores operational reliability. With that foundation in place, Genoa can strengthen Europe's supply chain resilience by diversifying entry points for global trade, positioning the new breakwater not just as port infrastructure, but as a national and European strategic asset. The core idea behind the new breakwater is deceptively simple: move the line of protection farther out to sea. Rather than reinforcing a century-old barrier clinging to the port's edge, engineers chose a far more radical solution, relocating the structure several hundred meters offshore and, in doing so, redrawing Genoa's maritime boundary entirely. The new breakwater extends for approximately 6.2 kilometers, forming a long, continuous offshore shield that intercepts wave energy before it can reach the inner harbor. Anchored in waters ranging from 40 to 50 meters deep, it ranks among the deepest breakwater projects ever attempted in Europe. With this expanded basin, ultra-large container vessels can enter and maneuver safely without relying on narrow weather windows or favorable tidal conditions. The reduction in wave agitation improves operational continuity during storms, cuts downtime, and enhances navigational safety for commercial shipping and port services alike. Yet, what appears straightforward on planning diagrams becomes extraordinarily complex in reality. constructing a multi-kilometer barrier at such depths, while one of the Mediterranean's busiest ports remains fully operational beside the worksite, transforms the project into a feat of precision marine engineering. Every design choice must balance protection against accessibility, ambition against constructability, marking the breakwater not as a simple coastal defense, but as a complete reinvention of Genoa's spatial relationship with the sea. The Genoa Breakwater project pushes maritime engineering into conditions few European ports have ever attempted to master, and its construction strategy is just as deliberate as its design. The new barrier is built from massive hollow concrete blocks, each weighing tens of thousands of tons, produced in specialized facilities, and floated offshore before being carefully aligned and sunk onto prepared foundations in waters that can reach 20 to 50 meters deep. At such depths, construction leaves little margin for error. Every operation depends on narrow weather windows, accurate positioning, and continuous real-time monitoring, particularly because the seabed varies in composition and the region carries measurable seismic risk, compounding the challenge. All of this work unfolds alongside one of the Mediterranean's busiest ports, which must remain fully operational throughout construction. To manage this complexity while delivering benefits as early as possible, the project is executed in two carefully sequenced phases. Phase A focuses on delivering the new operational gateway first, building the new eastern entrance with an access channel over 300 meters wide, an expanded maneuvering area with an 800-meter turning circle, and a widened Sun Pier Darena navigation channel, expanded to 500 meters, to serve Genoa's western port district. Targeted for completion around 2026 to 2027, this first stage is also where the breakwater's scale becomes tangible. Over 90 caissons are planned to form roughly the first 4 kilometers of the new offshore barrier. Phase B, running to 2030, completes the remaining works and the full operating configuration. The Genoa Breakwater project carries an estimated cost of $1.5 billion, placing it among the largest port infrastructure investments in Italy's modern history. This figure reflects not only the physical construction of the offshore barrier, but also the years of work that made it possible: design development, engineering plans, environmental mitigation, and the monitoring systems required for a structure of this scale. That groundwork was formalized in January 2019, when the project was approved under Genoa's Accelerated Infrastructure Program. After design and procurement progressed, the main construction contract was awarded in October 2022 to WeBuild. Offshore works then began in May 2023, publicly marked by the first stone ceremony, signaling the shift from planning into full-scale marine construction. Viewed over its full lifespan, the expenditure is framed as a long-term investment, one intended to secure capacity, reliability, and resilience for decades, rather than deliver short-term gains. Delivering such a project demands a governance and funding model equal to its complexity. Financing blends Italian public investment with European support. Oversight sits with the Port Authority, while delivery is carried out through a tightly managed network of contractors, technical teams, regulators, and supervisory bodies, structured to move fast without losing accountability. In that sense, the breakwater is not only an offshore build, but a real-world test of whether today's European systems can deliver megaprojects under intense technical, environmental, and public scrutiny. Once completed, the new breakwater transforms the Port of Genoa from a weather-constrained harbor into a far more predictable and competitive logistics gateway. Ultra-large vessels will be able to enter and exit with greater reliability, reducing dependence on narrow tidal windows and volatile sea conditions. For terminal operators, this stability improves berth planning, crane utilization, and yard operations, while shipping lines gain greater schedule certainty. These efficiencies cascade through supply chains, cutting delays, lowering operating costs, and reducing emissions caused by vessel queuing and route diversions, incremental gains that deliver significant economic value at scale. At a regional level, the breakwater strengthens Genoa's position within an intensely competitive Mediterranean port system. By accommodating the world's largest container ships and linking them directly to high-capacity rail corridors, Genoa becomes a credible alternative to rival southern hubs and selected northern European ports, with the potential to rebalance continental trade flows. Although offshore, the project's impacts extend deep into the city, easing congestion, supporting employment, and reinforcing long-term urban regeneration along Genoa's waterfront. As the Genoa Breakwater project moves toward completion, its true significance will unfold over time rather than at the moment the last caisson is placed. The structure is designed to endure for generations, providing the stability needed for the port to adapt as ships grow larger, trade routes evolve, and climate pressures intensify. More than a response to present constraints, the breakwater establishes a platform for future modernization, enabling terminal upgrades, smarter logistics integration, and deeper connections between Mediterranean shipping lanes and Europe's industrial core. In a century increasingly defined by uncertainty, the project represents a rare act of long-term thinking. It acknowledges that resilience in global trade is built not through incremental fixes, but through foundational investments capable of absorbing shocks and sustaining continuity. For Genoa, the breakwater marks a transition from reactive adaptation to strategic readiness. For Europe, it signals the continued relevance of Mediterranean gateways in a shifting global economy. Ultimately, the project stands as a reminder that the most consequential infrastructure is often the least visible, quietly shaping how cities, nations, and markets endure change.